Let's look at this second example, which corresponds to the block diagram, where we're going to reduce this block diagram to its simplest form. Once again, let's see how we're going to reduce this block diagram. We need to select 2 or 3 elements that we know how to manipulate in the same way, just like we did in the previous example. And of course, in the first video, which is the foundation for all these examples we're working on. Here, in this case, it's clear at first glance that we have 2 main loops, a feedback loop on the left and a feedback loop on the right. In this case, for this example, I intend to work from right to left, aiming to simplify this block diagram as much as possible. So let's begin. Initially, here we can take these elements from the block diagram, where I want to move this branching point to the other side of the block. Let's remember how we did this. If we refer to the block diagram table and apply operation number 8, we see that we have a branching point, and to move it to the other side, it's enough to place the block on the lower branch. So let's do that. We're going to move this branching point to the left side of G4, and this G4 needs to go into the feedback path, meaning it should be placed here in the feedback loop alongside H2. If we do that, we now move the branching point and place the block G4 in this case in the other branch. So now we have 2 G4s, and we've managed to complete our first operation. Let's continue here. As you can see, we have 2 branching points together. We had seen that these points, this line or this arrow, are all the same point. In other words, this arrow goes up here and down here, or goes to G4, it's all exactly the same point. And I can swap these branching points. Let's swap them. I move this point to the right, and this one to the left. Let's see now that here we're already arriving at a somewhat more familiar form. Initially, then, here, since we have 2 blocks in series, we had seen that according to equation 4, both blocks in series can be combined into a single block where both blocks are multiplied. So let's do that. We multiply both blocks, resulting in H2 times G4. Here then, we see this inner block, which is simply a feedback block, the well-known feedback block, which is operation number 13, corresponding to G1, over 1 plus G2, with G1 being the forward path block and G2 being the feedback path block. If we perform this operation here, in this feedback loop, we will have AG3, which is the forward path over 1 plus. In this case, since the summing point is plus minus as we see here in the operation, we have a plus here, and if we had a plus here, then there would be a minus here. So again, the block below would be H2 times G4 in this case, and multiplied by the forward path block G3. So it would be 1 plus H2 G3 G4. So can we then substitute this block for the feedback? We are now reducing this block diagram more and more. Now, for example, here I can again consider moving this branch point to the left side to continue operating. Once again, we apply the same operation number 8. So we move the block here and place it in the feedback path. Let's remember, this is the block. We had the branch point here, and we move it to the left. But then, the block has to remain on the other line of the branch. So here, we repeat the block, which is the closed loop G3 over 1 plus H2 G3 G4. So we are reducing this block diagram, which, as you can see, is a bit more complex compared to the previous exercise. By the way, if you haven't seen that previous exercise, click on this card to watch it, since that one was much easier to solve. But they are the foundation for solving any block diagram. Again, these 2 blocks are in series. I can multiply them or combine them into a single block. If we do that, then I can perform that operation, and, additionally, let's remember that here I have 2 branch points that are exactly at the same spot. I can swap them, put this one on the right and this one on the left. So let's do those 2 operations here. So now I've swapped the branch point, and here I've already multiplied the 2 blocks I had H3 by the feedback block. And we can see that little by little, we're once again arriving at some familiar blocks here. For example, if we look at this block here, once again it corresponds to operation number 13, which is feedback. So let's not get confused here. Notice that feedback is usually here, for example, in the formula we draw it going downward, but in this case it's going upward, but it's exactly the same. The key is not to get confused. Notice that here we already have 2 plus signs in the equation, and we have a minus sign, which is why it ends up as a plus here. Thank you. But if in this case there are 2 plus signs, then here we'll end up with a minus. When we do that, we see that this is the direct loop. So in this case, it's this G2 divided by the feedback, which would be 1 minus, because here I have 2 plus signs a direct loop, which in this case is G2 times the feedback loop, which is all of this. So multiplied by h2 g3 g4 over 1 plus h2 g3 g4. We can work this out mathematically by simply reducing the terms. I'm going to arrive at this operation. If you want, you can pause and analyze the operation. This is basic algebra, so that later we can reach this other representation simply by expanding the parentheses. That way, I could get to this block diagram. So, can I substitute all of that with a single block that represents this entire operation? Mathematically, that's what we do. So, I've reduced that whole block to this mathematical operation, which I've shown here above. Thank you. This is just so you can see it more clearly. Below, in the comment section, it's open for you to tell me anything you want. Are you learning from these block diagram videos? Have you learned anything about control systems on this channel? I'd love to know, so I can keep improving the production of this channel. I'm looking forward to your comment. So, as we can see, everything is already being simplified. We've already eliminated the first loop, and now we've reached the second one. This loop carries the entire load in a feedback loop, and in this case, will end up with blocks in series. So let's proceed to solve this feedback block. Once again, we apply the same equation number 13. We multiply the entire forward path, which in this case is g1 times this whole operation, g1 times this entire operation, divided by the feedback. Again, we see that it's negative feedback, so it would be 1 plus g1 times all of this times h1, which is the block in a feedback path, as we can see here. We can also work this out mathematically. If we factor out the common term in the denominator here, we get this operation. Here, we can cancel denominator, and we can simply arrive at this reduction, which would then be a large operation, a very large block. But this is the operation we would end up with. You can analyze it yourselves. It's basic algebra. We've significantly simplified that block diagram. Now, we're just left with this part here, 3 blocks in series. We know that these 3 blocks in series can simply be multiplied together if we apply equation number 4. Let's get to this operation. Here, we have the operation of the 3 multiplied blocks. We proceed mathematically. I'm simply removing parentheses here. And finally, we're going to arrive at this operation, at this single block, where we've reduced the entire block diagram. So here, we're simply applying the laws of block diagrams in practice. Subscribe to this channel so you can keep learning more about control theory. You've already seen that we managed to reduce our block diagram, but now we need to verify whether this reduced diagram actually matches the original diagram. To do that, we're going to compare them using Simulink. All of this mathematical development, along with the codes, can be downloaded for free from the website, and the link is in the description of this video. We're here in Simulink to start with, the .m file. Example 1 loads all the default blocks. So we need to run that file so that all the blocks are already loaded here before opening Simulink. That exercise will be exercise number 2. If we open it, here we have the Simulink file open, and we can see that all the blocks we previously loaded are already here. G1, G2, G3, H1, H2, and so on. Each block then is fed by a step input. Let's go ahead and click Simulate here. We can then observe the output response of the original block here in this scope, and we see that it has a response very similar to a second order system, an oscillatory one. Did our reduction turn out similar? In fact, it turned out exactly the same. Let's look at the only block down here. If we open it, we see that it is indeed the same response. So we've arrived at a completely equivalent response. In fact, here I have a comparison scope that takes the response from my original diagram and compares it with the response from the reduced diagram. Let's open it up, and once again, we see that there's only a single line, which means one is overlapping the other. The top one gives me a yellow line, and the bottom one gives me a blue line. We can see that the bottom line overlaps with the top one, which is why we don't see the yellow line. This indicates that both systems are equivalent. If you dedicate yourself to practicing block diagram exercises, in no time you'll have the mastery you need to solve any system using block diagram. So first, subscribe to this channel so you can keep learning even more. I also invite you to check out our control systems playlist and watch our third example of block diagrams that we have here. The comment section is open as well, so you can share your thoughts with me. What do you think about these courses? See you in the next video.